welcome back. We are today going to be talking about supply and demand a little bit more. We're going to be expanding on what we talked about last time, and we're going to be going into the stuff that makes this model actually interesting and useful. So before we do that, let me just briefly plug one more time my book, A Step-by-Step Guide to the Principles of Microeconomics. If you find this video useful and you are not already in my class, maybe consider picking it up. It will help you figure out how to solve the questions that you will see in your own class. That said, let's get started. So first, we're going to get a little bit of a recap on what we talked about last time. We talked about the supply and demand model, and we talked about sort of what is the basic idea going into both the supply side of the supply and demand model and the demand side of the supply and demand model, and how they come together to give us an equilibrium point that we can predict. Sort of that's where the market for that good is going to go. So what do we find out? So first, we talked about the demand curve. We said that the demand curve represents a relationship between price and quantity demanded. Okay, what that means, right, is that we have a price. I can tell you a price and say, okay, at this price, how many units do people actually want to buy? We also know that the demand curve is going to tell us about the marginal value that people place on the good, which is also their reservation price. It's the most that they're willing to pay for that good. It's going to be written right in there on our demand curve like we want it. And lastly, that the demand curve slopes down. We also talked about the supply curve. The supply curve is a relationship between price and quantity supplied. I give you a price, and then the supply curve will tell you, okay, if that were the price, this is how many units people would want to make. And we also talked about the supply curve showing you what the marginal cost or the reservation price is for suppliers, for producers. There is a cost in bringing a good to market, not only in terms of the direct cost of production, what you have to spend in order to make something, but also in terms of their opportunity costs, what they have to give up in order to make this good instead of something else. That will give you their reservation price, the lowest price that they will accept in order to be able to be willing to make something. If you want to get somebody to do something for you, you have to at least cover their costs. Right? That would be, you have to pay their reservation price. Lastly, the supply curve slopes up. The higher the price of something is, the more people are going to want to make and sell it for you. We also talked about the equilibrium, the concept of equilibrium, and we said that the market is going to reach equilibrium where supply and demand cross. That is the point at which there is no cash left on the table. When you are at the equilibrium point, well, we know, of course, that we can get quantity demanded from price once we have the demand curve. If we follow price over, we can see that quantity demanded is right there at Q star. If we look at the supply curve, we can follow price over and see that quantity supplied is also Q star. There's no difference, right? At this particular price, quantity demanded is equal to quantity supplied. That's what equilibrium quantity is. And when those two things are equal to each other, nobody really wants to change what they're doing. Everyone's happy just sort of sitting where they are. Everybody who wants the good either already has it or doesn't value it enough to be willing to pay somebody to make it for them. And everybody who is thinking about making the good either is already making it or is not being offered enough money to make it worth their while. So nobody wants to change anything that they're doing. We've reached the equilibrium, calm, resting point of the market. So, with all that said, we're going to talk today about how we can take that model and how we can think about how change in the market is going to affect what's going on with supply and demand. What's going to change the demand curve? What's going to move it around? What's going to change the supply curve and move that around? And when the demand and supply curves change and move around, well, what's going to happen to that equilibrium price and quantity that we're interested in? Now, you might remember a while ago when I was talking about the production possibility frontier, I said that, well, drawing the production possibility frontier doesn't really tell you a whole lot that you didn't already know. Similarly, drawing a supply and demand set of curves down doesn't really tell you a whole lot that you didn't already know either. You can get the equilibrium price and quantity, but only if you knew what the underlying formal expressions for the supply and demand curves are. If you wanted to check that against the real world, well, you would just check it against the actual price and quantity that you see for the good in the real world. And if you know that, then you don't need the supply and demand model to predict it for you. So what's the point? Well, just like with the production possibility frontier, the interesting stuff with the supply and demand model is going to come in, not when we write it down the first time, but when we start changing things around. This is where the usefulness of the supply and demand model is going to come out. Even though we're talking about a competitive market specifically, even though, as I mentioned, a lot of modern markets are not that competitive, we're still going to have some interesting things to say about the way that markets, including modern markets, work when we think about what's going to shift supply and demand around. How are they going to move? So let's think about what's going to happen when supply and demand move around. And let's just start with the basic graphical idea. Let's forget for a second about all sorts of intuition. We don't care about what's actually happening in the real world for a minute. Let's just talk about the graph and see what's going to happen mathematically and graphically when we start moving these things around. All right, let's try that out. So we're going to draw a supply and demand curve. So we're going to start out with what we already had before. Okay, we're going to have our axes. We'll have price up on the y-axis. We'll have quantity down on the x-axis. We will draw supply sloping up. We will draw demand sloping down. Okay, and we have our equilibrium price and quantity where the two cross. I'm going to put P star for the equilibrium price and Q star for the equilibrium quantity. Great. So far, so good. We're up to what we had last time. Let's move things around. So let's start out moving demand. Let's say that there's going to be more demand, an increase in demand. So first of all, we're going to express this on this graph by taking the demand curve and shifting it to the right. I'm realizing that you're looking at me the other way, so it would be to the right. There we go. Okay, so we're going to take this and we're going to move it to the right. Now, why do we move it to the right? Well, because basically what we're saying is when there's an increase in demand, we're saying if the price stayed the same, if the price was the same as it was before, we would want more of it anyway. Right? And that's what's happening with a shift of one of these curves. We're saying that if the price stayed the same, we would see a change in the quantity demanded. Right? We already know what's going to happen if the price changes. We're going to move along that demand curve. Right? The demand curve already tells us what we are going to do with a price curve, how we're going to respond to a price change. So what we're interested in when we're thinking about shifts in the demand curve itself, actually moving the curve itself, we're thinking about when the price stays the same, will we want more or less? That's going to give us a demand shift. So we're going to move it to the right to indicate an increase in demand because we're going to say at the same price, we want more quantity. More quantity is to the right. So let's draw that in here. We're going to take this demand, we're going to point an arrow right there, and we're going to just draw a new demand curve over to the right of it. I'm going to mark it with D prime. Prime is just a shorthand that economists tend to use for the new one. Okay, and that prime is just a little dash right there. Okay, and then what's going to happen to our equilibrium price and quantity? Well, the rules for finding the equilibrium price and quantity with the new demand curve are the exact same as they were for the old demand curve. We're just going to look for a supply and demand cross. It's just now we're looking at a new demand curve. So our equilibrium price and quantity is going to be where supply and demand cross. And we can just get that cross right there. Follow those lines up and down. We get P prime and Q prime. There we go. That's it. So we see an increase in demand. We end up with a higher equilibrium price and a higher equilibrium quantity. Does that make sense? Okay, well, people want this stuff more, right? They've increased their demand for this good, and so they're willing to pay more for it, right? So the price is going to go up, and they want more of it, so the quantity goes up. Okay. Now, don't get too confused, right? I did talk earlier about the price staying the same, and we see the demand curve. We see the demand curve going right. After that's just one way of describing what's happening when the demand curve shifts. The equilibrium itself is going to change. The equilibrium price is going to change after that shift happens. And so here, even if the price had stayed the same, we would want more. But the suppliers are going to take advantage of that fact a little bit, and they're going to say, okay, well, if the price had stayed the same, you'd want more, but we're going to raise the price a little bit. We're going to trade off a little bit of the fact that you want more of it. Instead, we'll only raise the quantity a little bit, and we'll raise the price some too. That's what we end up with. Okay, so that's an increase in demand, a shift of demand to the right. Well, let's think about what else might happen. Let's think about a shift of demand to the left. Same idea here. We'll draw out a brand new set of supply and demand curves. And we'll have our equilibrium price and quantity. And we're going to shift demand to the left. Same idea as before, except we're going to go to the left instead of to the right. And same idea as before, we will find our new equilibrium where supply and demand cross, the price and quantity at which supply and demand cross. So demand shifts to the right, equilibrium price and equilibrium quantity go up. Demand shifts to the left, equilibrium price and equilibrium quantity go down. People want less of this, so they're not willing to pay as much for it, and they don't want as much of it. Price and quantity go down. So that's demand. Let's talk about supply. Let's draw the same set of axes that we had before, Q and P, and we will have supply there, and we will have demand there. And our good old starting equilibrium price and quantity, P star and Q star. Now we're going to have an increase in supply, which means that we're going to shift supply to the right. So we're going to shift supply to the right, same idea as when we shifted demand to the right. We're going to draw our new supply curve, S prime. And we'll get our new equilibrium price and quantity, yet again, where supply and demand cross, P prime, Q prime. Now what happened here? So this time, you can see that the equilibrium price went down, and the equilibrium quantity went up. So with demand, price and quantity, when demand shifted around, price and quantity tended to move in the same direction. When supply moves around, price and quantity tend to move in different directions. Does this make sense? Okay, there's more supply. People really want to provide this good to you. That's what they're doing. So we see an increase in supply. People will increase their desire to sell this good to you. They really want to sell this. So you probably don't have to offer them as much money in order to get them to do it. Price goes down. Also, they really want to give it to you, so the quantity goes up. There's more that they want to give to you. So equilibrium price goes down, equilibrium quantity goes up. Makes sense to me. One last direction we have to do. We're going to have a shift in supply to the left. P up there, Q down there. Supply, demand, starting equilibrium price and quantity. This time we'll have a shift of supply to the left. And we will end up with our new equilibrium price and quantity. Okay, supply shifts to the left. People don't want to provide this thing so much anymore, which means you got to offer them more money to get them to do it. Price goes up, and they don't want to do it so much. Quantity goes down. So we got these four shifts, and that is really it. That's it. That's the whole thing. Supply and demand, we got two of them. They go left or right. So we got four different things to concern with. That's really the entirety of the whole situation. So if we're just talking about what happens graphically, this is it. So we have supply, we have demand, they shift left or right, we see what happens to equilibrium price and quantity, or what we predict is going to happen. So we've got the graph down, we figured out what's going to happen with the graph. So now let's think, well, why are these shifting? I said a minute ago that we're going to forget about intuition and what's actually going on in the real world for a while. Now it's time for that stuff to come back. Pesky, isn't it? So what we're going to do is we're going to think about what is actually going to cause these curves to shift. And this is where the usefulness of the supply and demand curve is going to come in, because what this means is that we can think about a change that's happening in the real world. Okay? Any change. You read a newspaper article about something happening in the world, you think this is going to happen in the future, whatever it is. And you're going to be able to translate it into thinking about, okay, I know what's going to happen. Which of these shifts is going to happen as a result? How can I translate this real world behavior into a supply or demand shift? Then, once you know what that is, you can predict what's going to happen to equilibrium price and equilibrium quantity. It gives you a way of predicting how prices and quantities are going to change in the future, which is pretty darn useful if you ask me. And that is what I said, right? Writing down the supply and demand equations in the first place didn't really tell us that much we didn't already know. But this is giving us a way to predict what's going to change in the future. That does tell us something that we don't already know. So let's think about how we can do this. Let's start by focusing on the demand curve and thinking about the things that can change demand, the things that are going to shift demand around. Okay? So I'm going to have this list of 5 things. They're going to be income, the prices of related goods, tastes for consumers, the expectations of consumers about the future, and the number of buyers in the market. We're going to go over these each one by one. So let's start with income. So remember that the demand curve comes about from a lot of consumers making a lot of consumer decisions about whether or not to buy something. Now, the more money that you have to spend, the more money you have to spend on this good, whatever this good happens to be. So if your income goes up, that means that you are likely to buy more stuff, even if the price of the good itself doesn't change. What does that sound like? Price staying the same, quantity demanded going up, that's a demand shift. So if the amount of money that people have changes, then that's going to shift demand around. Generally, an increase in people's income means that the demand for a good is going to shift to the right, is going to increase. That's what normally happens. So when that happens, when we see that income goes up and that shifts demand to the right, we're going to call that a normal good. Now, this doesn't always happen. Most goods are normal goods. The more money you have, the more you can afford to spend, and so the more demand you're going to have. It's shift in demand to the right when your income goes up. However, some goods are what are called inferior goods. These are goods for when your income goes up, you want less of them. These are typically the kinds of things that you only buy because they're really cheap. So let's take, instant ramen, for example. You might be a consumer of instant ramen. You might enjoy it. But generally, people buy instant ramen because it's super cheap. They only buy it because they can't afford anything else. So when their income goes up, that means they're actually going to want less instant ramen because they're going to substitute away to other goods instead. Okay? So that is the idea of an inferior good. In this class, at least, we're going to focus mostly on normal goods. If you think about income changes, you can generally say that as income goes up, demand shifts to the right. So that's one determinant of of demand shifts. Next, we have the price of related goods. So I've sort of drilled into your head last time that the demand and supply curves do not shift just because prices change, right? Price goes up, you're going to want to buy less of the good. But that doesn't mean the demand curve is shifting to the left. It just means that you are moving to a different point on the demand curve with a lower quantity demanded, right? Now we're going to break that rule a little bit, but again, the change in the price of a good does not shift the demand or supply curve for that good. But it could shift the demand or supply curve for other goods, right? Because those other goods, their demand curve is they're a relationship between their price and quantity demanded. They're not a relationship between this price and quantity demanded. So when you see a price change in one good, you can see a demand or demand shift in another good. We have two different ways this can happen. One is substitutes. If two goods are what are called substitutes for each other, meaning that you typically want one or the other but not both, then you can imagine how the price of one might affect demand for the other. A good example of this is butter and margarine. If you have a lot of butter at home, you don't need to buy a lot of margarine, right? So let's imagine for a second what might happen if the price of butter goes up, okay? So let's actually draw this out. Let's say that the price of butter is going to go up. So we're going to start out with the market for butter, and we're going to draw right next to it a very similar looking set of curves for margarine. We got supply, we got demand, and we have butter over here on the left, and we have margarine over here on the right. So let's say, for example, that something changes about the price of butter. Let's say for some reason that supply has shifted to the left. That is going to increase the price of butter. Okay, we see a new price of butter. It's higher than it was before. This also comes along with a lower quantity demanded of butter, right? Price goes up, quantity demanded goes down, just as we'd expect. Okay, so what's going to happen then for the market for margarine? Now, remember, margarine and butter are substitutes. The more you have of one, the less you want of the other. And we've just determined that the amount of butter that people are going to buy is going down, which means they're going to need to buy more margarine to fill in the gap, right? They don't have as much butter anymore. They're going to want to buy more margarine. And so when the price of butter goes up, the demand for margarine is going to shift to the right. There we go. They're substitutes. So one of the things gets cheaper. People get more of it. Then people are going to want less of the other good. Demand's going to go down. Or in this case, the price went up. People are going to buy less of it, which means you're going to want more of the other thing to make up for it. You substitute quantity of one thing for quantity of the other. And your demand curve is going to move in order to sort of compensate for that. So that's one way it can happen, is substitutes. Another way it can happen is complements. These are goods that tend to go together. And in proof that I have not changed my slides for a while, the example that I have here is CDs and a CD player. If you have a lot of CDs, then it makes more sense that you're going to want a CD player to go along with them. Similarly, if you don't have any CDs, then you don't really need a CD player. Right? You're not going to be willing to buy one no matter what the price is. right? So let's think about what might happen if the price of one of those things changed. Let's imagine for a second that the price of CD players goes up for some reason. Now that means that the quantity demanded of CD players is going to go down, right? Law of demand, price goes up, quantity demanded goes down. Which means that fewer people are buying CD players. Which means that fewer people need CDs to go along with their CD players. Which means that the demand curve for CDs will shift to the left. As things go together, you got less of this one, so you also need less of the other. So the price of one good can affect the demand curve for related goods. And just to sort of sum it all up, if the price of a substitute increases, demand will increase because you want to trade off the one that it just increased. You buy less of that one, you buy more of this one. And if the price of a complement increases, then demand decreases, right? Price goes up, you buy less of it, so you need less of the other thing to go with it. And you can imagine lots of examples of goods that go together, right? Pencil and paper, apps and your phone. If the price of an app was $1 million, you probably wouldn't bother buying a phone, right? Your demand curve for phones would shift to the left. All right, so that's one other thing. We got the prices of related goods. Next up is tastes, consumer tastes. And this one's pretty straightforward. One of the things that goes into the demand curve, as we mentioned before, is the marginal value, how much value people place on the good itself, right? So if something changes about that for any reason, that's going to move the demand curve around. So consumer tastes change, that's going to shift the demand curve. Some things are going to become more or less desirable simply because of the change in those tastes. So here we have an example. We have bell-bottom jeans. The popularity of bell-bottom jeans has shifted as time has gone on. When bell-bottom jeans are particularly popular, right, and when they're really in style, everyone really values having a pair of bell-bottom jeans, that is going to shift demand for those jeans to the right. And when nobody wants them anymore, they're going to shift back to the left. This one's pretty straightforward. We don't have to spend a whole lot of time of it, which means we can go to the more difficult one of expectations. This one's a little bit difficult to think about, but the basic idea here is you're trying to anticipate what the price of this good might be in the future. Okay? So think about it for a second. So let's imagine that you're thinking about buying something, but you think that the price of that thing will go down in the future. It's going to be cheaper in the future. So what are you going to do? Well, you're going to wait. You're going to wait to buy it until it's cheaper, right? And waiting to buy it basically means that you're not going to buy it today, right? Which means that your demand today for that good is going to go down because you expect that it will get cheaper in the future. Similarly, if you think that the price is going to go up in the future, you're going to buy it right now. You're going to buy it immediately before you get stuck with that high price. So if you expect that the price is going to go up in the future, that will shift your demand to the right because you're going to try to buy it right today instead of waiting for that price to go up, which you don't want. One example of that is the Xbox. So we got the Xbox, right? We always know that there's going to be a new version of the Xbox coming out sometime in the future, right? Let's say you're interested in buying an Xbox, but you know that the new one is going to be coming out sometime soon. And you also know that when the new Xbox is announced, the price of the old one is going to go down. Okay? So, because that new one is announced, right, and that suddenly makes the old one obsolete. And also, everyone's going to be trying to sell their old one in order to have some money for the new one. So the price of the old one is going to go down. So what's that going to do to the demand for the Xbox? Well, you're going to want to wait if you think it's going to be pretty soon for the new one to come out. Even if you really want the old one, you're going to wait because you're going to wait until that price goes down. It'll be cheaper for you. So that means that when you think that the new Xbox is going to come out, it's going to shift your demand for the current Xbox to the left. You can also think about this sort of being like the stock market a little bit, right? If you think that the price of something is going to go up, you're going to buy it. If you think the price is going to go down, you're not going to buy it, right? You don't want to get in on that bad investment. Another thing that's going to shift the demand curve around is the number of buyers. So you remember when we were talking about the demand curve and I was saying that it represents all the people who might buy the good if the price were right, okay? But that's not everybody. Depending on some people would start buying when the price got low enough, but some people would never even consider themselves to be in the market. So, for example, I am not currently in the market for restaurant meals in Berlin. I'm not in Berlin. No matter how cheap a restaurant meal gets in Berlin, I'm not going to buy it, right? It could be free, and I would not be getting on a plane to go to Berlin to get a free meal, right? right? So I am not in the market for a Berlin restaurant meal. But what happens if I go to Berlin? Well, then suddenly I am in the market for a Berlin restaurant meal, which means that the number of buyers in the market for Berlin restaurant meals has gone up, which means that the demand is higher. Because even if the price is the same as it was before, well, I've just added myself to the equation. And now I'm going to buy a restaurant meal, which means that the quantity demanded of restaurant meals at the same price has gone up, which, as we mentioned before, is basically what we're describing when we say that the demand curve shifts. So anytime that you see a change in the number of people who would consider themselves to be a part of this market, potential buyers, it's going to shift the demand curve around. One common way that this happens is through just a change in the number of people, right? If you get a huge tourism wave in Berlin, that's going to see the demand curve for Berlin restaurant meals shoot way up, which is exactly what you'd expect, right? A lot of more people around who want to buy something, demand goes up. You could also imagine immigration. You could bring a lot of immigrants into the country. That's going to increase just in general the number of consumers. And so the demand curves for all the consumable goods in that country are going to go up as a result. So there's lots of different ways it could change. You could also find a new usage for some good, which lets it find a market that it did not have before. One example of this is helium. So you go back not that long ago, and most of the time when you were using helium, it was to inflate a party balloon. Pretty fun, right? But then they discovered the MRI machine, or they invented the MRI machine. Now the MRI machine uses helium as a part of its process of imaging, medical imaging, in order to help diagnose and cure diseases. So what's going to happen to the demand curve for helium when this MRI machine that uses helium is introduced? Well, that's going to increase the number of buyers in the market for helium, right? All these medical suppliers would never have considered buying helium before that. Why would they bother? But now they have a reason to. That's going to bring them into the market for helium. It's going to shift the demand curve to the right. And what that's going to do to price? It's going to increase the price. A rightward shift in demand will increase the price. And that is, in fact, exactly what we see. Helium prices have been inflating a lot recently. And in fact, it's getting to the point where a lot of that original use, the helium party balloon, sometimes it's not worth it anymore to spend that precious helium on inflating a balloon. And so those balloon suppliers are getting priced out of the market. Which actually sort of reflects one of the powers of the market. I talked a while ago about how one of the things that the market does is it allocates goods to the people that value them the most. Who do you think provides more value out of the helium? Is it the person who's inflating a party balloon, or is it the person who's using it to run an MRI machine in order to save somebody's life? Probably that one, right? So we think about these helium balloon providers being forced out of the market and think, oh, well, that's a kind of a sad thing. I like party balloons. But what this is really reflecting is taking that scarce resource of helium, facing a trade-off, and allocating that scarce resource to its most productive use of medical imaging. All right, so that's a bunch of shifts, things that shift the demand curve. Let's go to the other side of the market and let's talk about what's going to shift the supply curve. We have 4 different determinants here, and a lot of these reflect the fact that the supply curve is really talking about production. It's talking about the ability to take an input and turn it into an output that you will then sell. And anything that's going to affect that process is going to shift the supply curve around. So the 4 things we're going to look at are changes in input prices, changes in technology, and then just like we had on the demand curve side, changes in expectations or the number of sellers. So let's talk about these one at a time. So first, input prices, right? What is production? What do suppliers actually do? They take some input and they do something to it and they turn it into an output. Now, that could be because you're running a factory and you're turning metal and wood and whatever into products that you can sell on the market, or it could be that you're doing something else and you're taking people's time and energy and as an input and you're turning it into something, right? If you run a hair salon, you are taking as inputs the time and energy of all the stylists that you hire and all those hair care products and etc., and you are turning them into beautiful, beautiful looking hair. So what's going to happen if the price of those inputs that you have to buy changes? Well, imagine that you're a car factory, for example, and you are producing cars. So what happens if the price of sheet metal, which is an important part of producing cars, goes up? Well, that means that the cost of producing a car has gone up. And remember that the supply curve includes the marginal cost. It is the marginal cost of producing that good. So if the price of sheet metal goes up, that means that cars have gotten more expensive to produce. The marginal cost has increased, which means that it's going to get more expensive, that supply curve is going to shift to the left. There's going to be less supply, a leftward shift in supply, simply because it gets more expensive to make this thing, so we're not going to make as much of it if you're only going to charge us the same price as before. Same price, less quantity supplied is a shift in the supply curve to the left. We can combine that and think about it in conjunction with technology, which is the second item. Now, in economics, we have a very broad view of the idea of what technology actually is. Technology is not just machines and things like that. It's anything that allows you to take those inputs and turn them into those outputs that you can sell. So it could be machines and things like that and software and whatever, but it also could be like a management technique. If you bring in a new manager and they're really awesome and they get everybody to produce twice as much stuff, then heck, that's a new form of technology. You just increased your production, right? It's just like you got a better machine in. Doesn't matter why there's more production, just matters that there is some. And so you get an improvement in technology, which means that you're going to be able to get more output from the same inputs. And that is going to make it effectively cheaper to produce something, which is going to shift supply to the right. If price stays the same as it was before, but you get an improvement in technology, it becomes cheaper to make each unit because you can get more out of all your inputs. And then you're going to be willing to produce more of those things at that same price. That's a rightward shift in supply. Similarly, if for some reason technology is diminished in some way, that's going to shift supply to the left. There's going to be less production. So to sort of sum up those two things, which are really describing the process of production, what sellers really do is they take some input, they apply some technology to it, they put their magic little fingers on it, and it turns into some product that they can sell. If anything changes about that process, you can just intuitively think, is this going to make the thing more expensive or less expensive to produce on a unit-by-unit basis? If it gets more expensive, that's a shift in supply to the left. Input prices go up, technology gets worse, supply shifts to the left. If something is going to make that process cheaper, so you can get make those products at a lower price, then that's going to shift supply to the right. So input prices get lower, or if technology improves, that's going to shift supply to the right. And keep in mind, remember, as always, one of those inputs that you have to have is your opportunity costs. So if, for example, your alternative opportunities get worse, then your supply in this good has just gone to the right, right? If I lose my job, and so I don't have so much of a valuable use of my time as what I'm doing right now, then I might find myself increasing my supply curve, shifting it to the right in some other task instead, right? Because my opportunity cost of spending time on that instead has gone down. My input price went down, my supply shifted to the right. And so the market supply would shift also a little bit to the right. Next, expectations. This is basically the same idea as for the demand side, except in the opposite direction, as you might expect. So in this case, let's say you imagine that the price is going to drop for something in the future. For some reason, you think that the price is going to go down in the future. So you're a supplier. What does that mean? Well, you want to sell off your stock right now before the price drops and you get stuck selling it for a low price. You don't want that. So if the price you expect is going to go down in the future, you are going to try to, that supply is going to shift to the right. Similarly, if you think that the price is going to go up in the future, you're going to hold on and you're going to wait to sell, which is going to shift your supply for right now to the left. And you can notice how this is going to actually work together with the demand side one, right? So if everybody thinks that prices are going to go down in the future, then that's going to shift demand to the left because they're going to want to wait to buy, and it's going to shift supply to the right because they're going to want to sell right now rather than get stuck with a low price. And you might note also that, well, what happens with a leftward shift in demand? Well, that's going to lower the price. What happens with the rightward shift in supply? That's going to lower the price too. So the expectations of price in the future becomes a bit of a self-fulfilling prophecy because you expect the prices are going to go down in the future, and so everybody acts accordingly because they don't want to get stuck with that low price. And surprisingly, whatever you thought was going to lower prices in the future has actually ended up lowering prices right now. Interesting how that all works out. So that's expectations, same idea as with demand. And additionally, number of suppliers is going to work out the same way as demand. Supply is just an aggregation of a bunch of different suppliers making stuff together. The more suppliers there are currently working in the industry means that the more there is to produce. at any given price point. And so if you get a bunch of new suppliers into the industry, into making this particular good, that is going to shift supply to the right. And if a bunch of suppliers leave for some reason, then that's going to shift supply to the left. That's basically it. So we've got these things that determine shifts in supply and demand. And we are going to be able to take this idea and we're going to apply it to be able to think about what's going to happen to prices and quantities when these very real world changes occur. So we have a number of steps to follow when we're thinking about what can we do with this. So when you think about any sort of change in the real world and you want to think, what is that change going to do? What effect is that change going to have on the various markets that I'm interested in? You can follow these steps. Number one, first, to determine whether that change affects supply or demand or potentially both. Second, once you've figured out what it affects, you can think about whether those shifts are going to be to the left or to the right. Next, you can then figure out, okay, well, I know based on the graphs that I already have, those 4 simple little graphs, that if I see a shift in demand or supply to the right or left, I can predict what's going to happen to price and quantity. And I can, therefore predict what's going to happen to price and quantity when this change occurs. Lastly, if you want to, you can then continue on and think, well, what effect is this going to have on the market? So for example, with the helium balloons, right, we could say, well, we know that when this new use comes in and all these new buyers come in, it's going to raise the prices, which might end up raising prices higher than is worthwhile for those balloon vendors to bother buying helium anymore. Let's take an example. Let's take a quick example of applying these steps. So we're going to do this on personal computers, okay? Now let's start out with the sort of pre-scenario. And what this is we're going to talk about the IBM 610 AutoPoint computer, the very first personal computer ever available from 1948 to 1952, just after World War II. You could be had for the low price of about $500,000 in current dollars. Or if you wanted to rent it, you could get it a little bit cheaper for only about $11,000 a month. Okay, it had about 2 kilobytes of memory, which if you're wondering how much memory that is less than anything you currently own. If you currently own a watch that tells you the time, it probably has more than 2 kilobytes of memory. This is what it looked like. So we have this sort of cabinet looking thing over here on the left. That's the actual computer. You can see the little slot over there on the left. That's where you would feed a punch card in with written instructions. That punch card, by the way, that you would have to write up yourself on that little typewriter thing looking thing over there on the right. You would feed it in those instructions. It would go chunk, 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 chunk as the card would go through the machine, and it would read that code. It would do whatever calculations you wanted it to have, and then it would spit out a little bitty piece of ticker tape with the answer. And so you'd go over to that little keyboard, you'd type in, what is 2 plus 2? It would chunk it out on a card. You'd take that card, you'd pick it up, you'd walk it over to the machine, you'd put it in, it would go chunk, 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 and it would spit out the answer of 4. Okay? So that's what we had, and since that point, as you can imagine, a lot of things have changed. So first of all, that big cabinet had a whole lot of clunky physical moving parts, right? You put that card in and it had to go through a card reader. And that's a lot of moving parts that are going to break down and require a lot of maintenance. So we've gotten rid of that. We have a lot of circuit boards now that don't require all those moving parts. We replaced all the vacuum tubes with transistors. The transistor is the little thing that tells the computer whether it's a 0 or a 1, so to speak. We replaced all that punch card machinery. We standardized the parts, right? Instead of just making a few AutoPoint computers and selling them for $500,000 each, we have millions and millions of computers out there with all standardized parts, which makes them cheaper to produce, right? A drop in those input costs. We standardized the software. That computer that I just showed you didn't come with software or like Windows. That wasn't a thing. If you wanted the computer to do anything, you would have to program it yourself. Lots of other technological advances I haven't listed here. So think for yourself, what is this going to do to the supply or demand curve? So first of all, let's follow our steps. Is this going to affect supply or demand? Let's just focus just on these changes that we have on the list here. Let's forget about any other changes. So is this going to affect supply or demand? Supply, right? These are all things that are describing changes in the production process, drops in input prices or changes in the technological production process. So we see a supply shift, and that supply shift in particular is going to be to the right. We see decreases in our input prices. That's going to shift our supply to the right. We see improvements in technology, also going to shift our supply to the right. And also, we didn't list it here, but we have a lot more computer sellers now than we did when it was really just IBM. So that's also going to shift supply to the right as well. So what would we predict based on this? Well, supply shifts to the right. We can look back to our graph. Think about it, write it down. And of course, we see that there should be an increase in the equilibrium quantity and a drop in the equilibrium price. And that is, in fact, as you probably already know, exactly what we see. So right here, I pulled up an ad for a computer, and it is about $300, and it is 4,000 times better than the AutoPoint 610, and it is 1/1800th of the price. So even though we got this massive increase in quality, that was not enough to defray the fact that we also got a huge increase in quantity, right? We sell millions of laptops now and at a much, much, much smaller price. Now, this is exactly by what we would expect based on the supply and demand model. So we've got an accurate prediction here. Now, you might be thinking we've left some things out. In particular, we forgot about all the other changes in the computer market that have happened between 1948 and today. I suppose, and you can probably agree that a lot of other things have changed. Now, particularly on the demand side. So let's think about what might have changed on the demand side as well. So first of all, a lot more people have gotten used to computers and gotten to like them. That's going to be a change in taste. That's going to increase the marginal value of having a computer, shift it to the right. There's a lot more software cheaply available, right? That's going to decrease the price of a complement good, which is going to shift our demand further to the right. The quality of the product has gotten better, right? The internet exists. That makes it more valuable as well. So that's going to also shift our demand to the right. More people are computer literate. More people know how to use a computer than they did in the days when you had to program everything yourself. So we have an increase in the number of buyers as well, which will also shift our demand to the right. Also, this one typically gets left off when you start thinking about this stuff, but incomes have gone up a lot. People just earn a lot more money today than they did in 1948. So that, again, will shift our demand to the right. And what happens with a demand shift to the right? Think about it, write it down, and we would see an increase in quantity and an increase in price. Oh, well, hold on. The supply shift to the right that we had said that we are going to get an increase in quantity, so we're good on that. But it also said we're going to get a decrease in price, which is fine. But the demand shifts that we just described suggest that we should get an increase in price. So which is it? It can't be both. Now, we do happen to know, with the benefit of hindsight, that it does have a decrease in price. But what I'm trying to highlight here is that without knowing the answer, we can't predict what's going to happen to the price here. If you took us back to 1948 and you said, okay, well, the computer today costs $500,000, and here are the things that are going to change in the future about computers. Okay, well, they're going to get a lot cheaper to produce, right? The input costs are going to go down, the technology is going to improve, a lot more people are going to enter the market. But also, people are going to want them a lot more. And they're going to be more useful. And people are going to really need them for their jobs and things like that. It'd be a lot harder for you to predict whether the price is going to go up or down. You could easily say, well, they're going to get a lot cheaper to produce, so we are going to be able to sell them for less. But also, people are going to want them a lot more. They're going to be willing to pay more. Maybe they'd be willing to pay $1 million for a computer. So what we're talking about here is what happens when we have two shifts at once. We have both the supply and demand curve shift. Up to now, at least on the graph, we've only shown what happens when one of them shifts at a time. If both of them shift at a time, we have the unfortunate result that without more information, one of those changes is going to be ambiguous. We're not going to know what's going to happen. And in this case, it's going to be price. Here, what I'm going to do is I'm going to draw two shifts at once. We're going to start with our old supply and demand, as you can see here, at that old equilibrium. And I'm going to draw a new supply and new demand, right? Both of them shifting to the right. And the way that I've drawn it, the price goes up. However, if I draw it a little bit differently, still with both of them shifting to the right, this time the price goes down. If I draw both of them shifting to the right, depending on how I draw it, I can draw it with an increase in price or a decrease in price. Now, we do know that the quantity is going to go up. That one we're pretty locked in on. But we don't know what's going to happen to the price. And you can sort of see here what this suggests is that it depends on how big these shifts are. If the supply shift is a lot bigger than the demand shift, that suggests that it's going to sort of win out. And so when it says, hey, the price is going to go down, it's actually going to go down. And when the demand shift is really big and really big relative to the supply shift, then that suggests that the demand effect is going to win out. So when the demand curve says price is going to go up, then price is going to go up. You can sort of see how I've gotten it here, where when I want the price to go up, I draw the demand shift as really big and the supply shift as really small. And when I want the price to go down, I want that supply effect to win out. I draw the supply shift as really big and the demand shift as really small. So let's talk a little bit more about how to work with two shifts happening at the same time. And it turns out to be pretty easy. We're just going to sort of combine the shifts that we already had from our single shift. So let's draw a little table, okay? We're going to have price up here, P star, and we're going to have Q star. And we're going to think about what's going to happen to these two things if we have different shifts in our demand and supply curves. So remembering from before, if we see a demand shift to the right, say demand goes up, then price is going to go up and quantity is also going to go up. If demand goes down, then price is going to go down and quantity is going to go down. How about if supply goes up? Well, if supply goes up, meaning it shifts to the right, that is going to shift price down and quantity up. And if supply goes down, that's going to shift price up and quantity down. Okay, that's exactly just what we had before, just expressed in a different way. So let's think about what happens if we have two shifts at once. All we're going to have to do is combine the two shifts that we're combining from this table. So let's draw another one. We got P star and we got Q star. Okay, now let's put two of them together. Let's say we got a demand going up and we also have supply going up, as we just had in our computer example. So let's think about what each of those individually say. So over here, let's look at what demand has. So with both of them shifting up, with demand shift up, it says that the quantity is going to go up. Right? I'm going to circle that up arrow under quantity. And similarly, supply going up says that quantity is going to go up. Those both agree, so that's definitely going to happen. So we are definitely going to see that quantity is going to go up. What about price? Well, the demand shift says that price is going to go up, and the supply shift says that price is going to go down. Those disagree. So without knowing more information about how big those two shifts are, we don't know what's going to happen. So I'm going to put a big question mark right there. That outcome is ambiguous. We don't know what's going to happen to price without having more information, just on the basis of knowing that they shifted. Let's work out the other combinations as well. Let's say that demand is still going up, but supply is going to go down. We're going to follow the same steps. So this time, it looks like the prices agree. When demand goes up, price goes up. When supply goes down, price goes up. So price is definitely going to go up. As for demand, when demand goes up, that's going to put quantity up. When supply goes up, down, that's going to put quantity down. They disagree, and so we don't know. I'm going to put a question mark there. It's ambiguous. How about when demand goes down and supply goes up? Okay, demand goes down, that tells us that price is going to go down. Supply goes up, that tells us the price is going to go down. Great. So price is going to go down. How about quantity? Demand goes down, quantity goes down. Supply goes down, supply goes up, quantity goes up. Those disagree, so we don't know. I'm going to put another question mark there. Finally, demand goes down and supply goes down. And if demand goes down, the price is going to go down. Supply goes down, price is going to go up. Those disagree, question mark. If demand goes down and supply goes down, demand goes down, quantity goes down. Supply goes down, quantity goes down. Those agree, so we definitely know that quantity is going to go down. So when demand and supply are moving in the same direction, we know what's going to happen to quantity, but we don't know what's going to happen to price. When supply and demand are moving in different directions, we know what's going to happen to price, but we don't know what's going to happen to quantity. And that's really it. That's the whole process. That's the thinking with supply and demand. It's thinking out incentives, thinking about how changes in incentives, we can think through those in changes in incentives, right? We want to reason about the world using incentives. That's what economists do. So we're going to think about the real world and we're going to put it in terms of incentives. How can we translate that real world change into a shift in the incentives faced by suppliers or consumers, right? How was that going to shift the supply or demand curve? And when we can think about that, we can then predict what's going to happen to the price and quantity of that good. We get a prediction about how the world will change based on the incentives. We are explaining how the world works and changes and shifts and finds itself where it is using incentives. And that's the basics of the supply and demand model. And I hope that you find it useful. And I would recommend giving yourself some practice problems. Go ahead and practice some of those problems. Once you get the hang of it a little bit, and maybe look around in the world, open up a newspaper, see what's happening in the world, and just think, well, what's this going to do to a particular market? You open up the newspaper and you see that the price of rubber is going up. Okay, well, what's going to happen to the market for shoes? You can probably figure that out pretty good from this, right? And things like that. Always try to think about how you can translate that real world stuff into the economic model, and then back. Because if you can't do that, there's no point in learning the model in the first place. All right, that's it. Thank you very much, and I will see you next time.